All right, today we're starting coordinate geometry and matrices. Okay, so this chapter starts off pretty straightforward. We're just solving linear equations. So hopefully we can all do this. If we move all the x's to one side, so 7x minus 5x, and move the 2 to the other side, I get 1 plus 2, which is 3. So we get 2x is equal to 3. Therefore, x is equal to 3 on 2, which is 1.5, but we can just leave it as the improper fraction 3 on 2. That's the preferred way to leave it. Don't write it as a mixed fraction of 1.5, because that 1 could look like 1 times a half, which is just half, which is the wrong answer. So improper fraction is the preferred option. Okay, number 2, solving simultaneous equations. Hopefully we can do this pretty easy. So here I'm going to use the substitution method. I'm going to move the y to the other side here. So I'm going to go x is equal to y plus 4, which is from equation 2. Okay, I'm going to sub 2 into 1. So I know that this is x, so this is y plus 4 over 5 plus y over 2 is equal to 5. Now I can do what I liked as long as I do to both sides of the equation. So if I times both equations by 5, I get y plus 4 plus 5y over 2 is equal to 25. Times them both by 2, I get 2y plus 8 plus 5y is equal to 50. So now I've got 7y is equal to 50 minus 8, which is 42. So y has to equal 6. Okay, dividing both sides by 7. And if y equals 6, I can put it straight into this equation. So I get 6 plus 4, which is 10. So x equals 10, straight from that substitution. And then we've solved both of the linear equations here. Okay, easy. Next board. Okay, here we go. We've got literal equations. Okay, a literal equation is an equation where all the coefficients and constants are pronumerals. So here we go. We've got, instead of having a number out the front here, the coefficient of x here is an a, coefficient on the x side here is b. So x is our variable, and our constants here, or our coefficients, are all just letters. Now these seem to be the same, but that doesn't make any difference. Let's just solve it how we would. Okay, so we'll move all the x's to one side and the constants to the other. So I'm going to have ax minus bx equals to, I'm going to move this b over to this side, so I get b plus c. Okay, if I take x out as a common factor here, okay, I'm going to end up with a minus b inside a bracket, x equals b plus c. Okay, on the left hand side. Okay, so these are now multiplied by each other. I can divide and solve for x. So b plus c over a minus b, and we're done. Okay, that's how you do literal equations. You can also do simultaneous equations, but you know that'll take a lot of time here, so let's just move on. Alright, this is a jam-packed full slide here, or board even. Okay, so let's just work our way through it easily. Coordinate geometry. For 2 coordinates here, we've got 2 points on the xy plane. Here's a point and here's a point. Okay, so we'll call this point 1. So it's got an x ordinate of 1 and a y ordinate of 1, or y coordinate of 1. Oh, not equal to 1, but that's just 1 point, and we call this one 2.2. So it's got an x and a y. Okay, so between these 2 points, if we want to find, what can we find out just from these 2 points? We could look at the distance between them. Okay, so the distance between them is all the way along here. Okay, so what's that distance equal to? Okay, the easiest way to look at that is to break it up into a right angle triangle here and use Pythagoras' theorem to solve for the hypotenuse, okay? So you're always going to solve for the hypotenuse because for the distance between them. And you know this side length is going to be the distance between the x points, or the difference between the x points. So we've got x2 minus x1, which is this distance here, and the distance between the y points, okay? So the height here, the difference in the y's, and that's going to give us, we can just put it in, square both of those, take a square root, that'll give us a distance here, okay? Very easy, just think of Pythagoras' theorem. The midpoint, okay, so where's the point that's halfway between the 2 points? So if I was traveling between the 2 points, where's that halfway point? Well, that's easy enough. We just want to find the midpoint between the x's and the midpoint between the y's. Okay, so the midpoint between the x's here, they've done this by calculating the average of the x points, which will give you halfway between them, and the average of the y points will give you halfway between them. If you can see what the halfway point is between, like if that was x equals 1 and x equals 3 here, you can easily see that the halfway point is 2. There's no point in adding them up and then dividing by 2. 1 plus 3 is 4, divided by 2 is 2. Like, it's extra steps for things you can already see. Okay. The gradient of the line, so what's the slope of the line? Okay, so you can imagine if you've got y2 minus y1, which we've already decided is this distance here, okay, the rise, or the fall in this case, over the run, how far you go this way. Okay, so this is the distance between the x, distance between the y, rise over the run, gives you the gradient. Now we're going to also remember, if we need to find an angle, the gradient is always equal to tan of theta. So what does that angle represent? It's the angle from the horizontal. Okay, so this angle here, right? Unless in this case it's more than 90 degrees, so we'll probably get a negative angle when we find theta, which gives us, if we do it on a calculator, which gives us the angle under there. Okay, so you're just going to be aware which angle you're getting. If you get a negative angle, you've got the angle underneath the x-axis. If you get a positive angle, you've got the angle above it. All right, so, and then of course we can calculate the straight line. So for any 2 points, we can draw a straight line between those 2 points and find the equation of that line. So there's lots of ways you can find that equation and different ways you can put it in different forms. Okay, this is our y equals mx plus c, the one that everyone first gets introduced to. Okay, when you've got the gradient and you know the y-intercept, you can just plug that straight in. Okay, so if one of the points is the y-intercept and you know the gradient, then that's a very easy formula to stick it into. If you've got the gradient and 1 point, or if you've got 2 points and you can calculate the gradient, then this is a fantastic formula to use, and people often forget it. So make sure this is my most common used straight line formula. Just stick everything straight in and you get the answer every time. Okay, and the last one, which I don't think I've ever used in my entire life, however, you could, okay, it's only really useful if you know both the y-intercept and the x-intercept. Okay, so if you've got both of those, you can stick it straight in there and you've got the formula. Okay, last thing to remember is if you've got two lines here, okay, if their gradients multiply together to give it -1, then the two lines are perpendicular. Okay, so sometimes you might have to find a line that's perpendicular to another one. Okay, so their gradients multiplied together have to equal -1. Okay, so let's do an example of that because that's a lot of board for one board. Okay, here we go. So we've got 2 points here. We've got 1, 5 and 3, -2. What's the distance between those 2 points? Okay, so we're going to use Pythag. So we're going to go to the square root. Now this is how I do it. Okay, I don't worry about the fancy formula. I just say, well, what's the distance between 1 and 3? Well, that's 2. Okay, 2 squared. Plus, what's the distance between 5 and -2? Well, to go from 5 all the way down to -2, I'm going to have to travel 7 down in a straight line. So that's 7 squared. Okay. There we go. That was much quicker than using the big formula and putting all in the different values. Okay, so I've got 4 plus 49. That's square root 53. So the distance is root 53. All right. Next point, midpoint. So I want to find the midpoint. So the midpoint's going to be a coordinate. Okay, so halfway between the x's, well, this is the example I used before, halfway between 1 and 3, that's 2. Halfway between 5 and -2. What's the halfway point between 5 and -2? Well, I want to travel 3.5 down from 5. So 3.5 down from 5 is 1.5. And I could just write 1.5, or I could write it as a fraction. I want to practice using those fractions. 3 on 2. Very good. Okay, the gradient, the rise over the run. So the gradient m equals, what have we got now? Okay, so what did we say we've already found the rise and the run here. So we've gone down 7, right, from here, and across 2 from there. So -3.5. Done. That's the gradient. And now, how do I find that angle that the line makes with the horizontal? Well, this is going to equal tan theta. So I want inverse tan of -7 on 2. And I've done this calculation somewhere else. Let me just change my page. So on my calculator, it gives straight away -74 degrees, about, approximately. That's rounding off. So you want to check the question and see if it wanted rounding off to any number of decimal places. But if it wanted the positive angle, okay, so what would I do? I want to add 180 to that. Okay, so if I want the angle above, you could say that's 100, so add 180 gives me 106 degrees. Okay, so that's the positive version of the angle there, roundabout. Okay, the equation, I'm going to change to blue because I sort of forgot to change colors. Okay, so the equation, well, I've got a point, I've already got the gradient, so I'm going to use my favorite equation, sorry, that's not it. That's my favorite, I should get it right. y1 equals mx minus x1. All right, so we've got to put our point in, y1 and x1, and our gradient n. Okay, so y minus, pick a point, so we'll go y minus 5 equals m, -7/2, of x minus x1, which is 1. Okay, and then if I want to get it into different forms, that's it. That's the answer. I could just leave it there unless they wanted the question in different form. So if I wanted it in different form, I could expand it out. Have -7 on 2x plus 7 on 2, plus 5, moving that 5 across to the other side. I can add these two fractions together. So I've got y equals -7 on 2x plus, now that's the same as 10 on 2. 10 on 2 plus 7 on 2 is 17 on 2. Okay. And I could leave it like that if they wanted it in that form. Or I can multiply everything by 2 and move my x's on the other side. So I could have 2y equals -7x plus 17. We don't like to look at that negative, so we'll move this across. So we get 2y plus 7x equals 17. So that's another third way you could write that answer. All right, last one. Just make sure this is the last page and I haven't skipped a board. Well, it's not actually the last one. It's this last one for the moment. All right, so we've got an application here. Now, ABCD is a rhombus that has vertices at 1, 1, 4, 5, 9, 5. Show that the diagonals are perpendicular. So what does this mean? Let's work it out. Let's draw the vertices on the XY plane. So 1, 1. Got a point there, 1, 1. That's my point A. Point B is 4, 5. So go across 4 and up to 5. We'll go there. So this is point B. And point C is 9, 5. So at the same level, but a bit further across. 9, 5. That's C. So if it's a rhombus, where is the point D going to be? That's what we've got to find out. It's going to be down here somewhere. If we're going to have a rhombus, remember a rhombus, all the side lengths are going to be the same. Okay, so all those distances have to be the same for it to be a rhombus. So if this went from 4, 5 to 9, 5, it went across 5. So you would think that this one would also go across 5. That'll take me to 6, 1. Yeah. So that's a very important bit of information. So the diagonals. What are the diagonals? Okay, so the diagonals are these ones. Okay, so the diagonals of those, across the rhombus. Okay, so we want to show that these are perpendicular lines. Okay, so the key to this one is to find the gradient of these lines. If we find the gradient, then we can show that when you multiply them together, it equals -1. Okay, so let's find the gradient. So M1 will go A to C. Okay, so M1, we could even write MA to C. Okay, that really tells what we're doing. Okay, so the rise, it's gone up 4 and across, how far has it gone across? It's gone across 8. Yeah, from 1 to 9 is 8. From 1 to 5 is 4. So that equals 1/2. Okay, so what's the diagonal from B to D? Okay, so the diagonal from B to D, you've gone down from 5 to 1. So we've got down 4 and across from 4 to 6. So we've gone across 2. Okay, so that is equal to -2. I should put it over here, -2. So let's check if they're perpendicular. MAC times MBD equals 1/2 times -2, which indeed equals -1. So if it equals -1, therefore diagonals are perpendicular. Wonderful. Okay, matrices. All right. Okay, so matrices look like this. Okay, so we've got rows of numbers and columns of numbers. Okay, so the dimension of the matrix. Okay, so the dimension of the matrix is the number of rows by the number of columns. So we'd say this one has 2 rows and 3 columns. So the dimension of matrix A is going to be a 2 by 3 matrix. Okay, and each of the numbers in the matrix, or we call them the entries or elements. Okay, often entries. Okay, so we've got an entry at 1, 1. Okay, so the ith row in the ith column. So A11 is just a 1. Or if we want A23, for example, so we'd look at matrix A, we'd go to row 2, item number 3, or column number 3, which is 9 on 2. Okay. All right, so we're going to do some stuff with matrices. Let's have a look. What can you do with matrices? You can add and subtract them. Okay, so in order to add and subtract them, they've got to be the same dimension. Okay, so what are the dimensions of these ones? These are both 2 by 2 matrices. matrices. Okay, 2 by 2, 2 rows and 2 columns. Okay, and to add and subtract, you just add the corresponding entries. Okay, so you look at the first entry, 1 plus 1, that's a 2. 2 minus, or 2 plus negative 1, which is just 1. 3 plus 0 is 3. 4 plus 8 is 12. Okay, so that's those two matrices added together. Now, if they were different sizes, then they wouldn't all have corresponding matrices. So you can't add up all matrices. They have to be the same size in order to add them. You can also do subtraction. If I change that to subtraction, you just have to go 1 minus 1, which would be 0. You've got to be careful here if you've got a minus and a minus. So 2 minus negative 1 is the same as 2 plus 1, isn't it? So it would be 3 in that position there if this was a minus. Okay. Scalar multiplication. Here we've got 2 times this matrix. I bet you can guess what we do. If you're scaling something, or scalar multiplication, you're scaling it up. You're making it bigger by two times. So it's going to stay, everything's going to be in the same ratio, but it's just going to be 2, okay, 2 times bigger. So you just times each entry by 2. So you get 2, 4, 6, and 8, and you're done. Okay, so scalar multiplication is really easy with matrices. Next one. Matrix multiplication. I don't know why I put an X in there. Matrix multiplication. Okay, now, although the other things were really easy, this is a little bit different to what we're used to with multiplication. Okay, so the thing we've got to know about matrix multiplication is you've got to look at the order. Okay, so this is 2 by 2. And this is a 2 by 1. So it's got 2 rows and only 1 column. Okay. Now, in order to multiply matrices together, right, the columns of the first matrix have to be the same number as the rows in the second matrix. So these two numbers have to be the same. If they're the same, you can multiply them together. If they're not the same, you can't multiply them together. Okay, and our result, okay, our answer is going to be we're going to have the number of rows in the first column and the number of the number of rows in the first matrix and the number of columns in the second matrix. Okay, so our answer will be a 2 by 1. Okay, so we know that this answer is going to be a 2 by 1. Okay, same size as this one, even though we're multiplying by 2 by 2 here. Okay, the answer is going to be a 2 by 1. All right, let's have another little look at how we do this. Okay, so the first entry, okay, is entry 1, 1. So we multiplied the first row by the first column. And the way you do that is you go across the first row and down the column. So you go 1 times 2, and then you add 3 times 3. Okay, so that's a little bit confusing, but you're going this way. You're going across here and down here. Okay, so 1 times 2 is 2. 3 times 3 is 9. Sorry, I almost got that wrong. 3 times 3 is 9. You add them up, so 2 plus 9 is 11. So 11 is the first entry point. Here, we've got 2, 1. Okay, so we go 2, 1, the second row, 2 by the first column. So 5 2s are 10, 4 3s are 12. Add them up, you get 22. So that one should be 11. 22 is the answer there. Okay, so that's a little bit tricky the first time you see it, but a bit of practice and you'll get that really quick. One thing to notice is that if you try to multiply matrix B first, that's not going to work because this is a different number to this. Okay, so when you they don't necessarily equal each other. Okay, so B times A is different to A times B. Now that's different to ordinary numbers because 3 times 4 is the same as 4 times 3. But with matrices, totally different story. Okay, we cannot the order matters in which you multiply them. Okay. Okay, the identity matrix. So what's special about this matrix? Okay, what makes it identity? It means everything down the diagonal here. Now the diagonal from top left to bottom right is called the leading diagonal. Okay, so everything down this diagonal is ones and all the rest of the entries are 0. Okay, so there's only 2 other entries in here. But if you had a 3 by 3 matrix, you have the diagonal down all being 1 and the rest of the entries are 0. Okay, what makes it identity? Well, let's see what happens when we multiply matrix A by the identity. So we get 1 times 1 and 3 times 0. So 1 times 1 and 3 times 0. So that's just 1. Okay, now if I want to get this point, I go first row, second column. So I go 0 plus 3, 5 plus 0, and 0 plus 4, and there's my answer there. It's the same as this. Okay, so multiplying the identity matrix is equivalent to normal numbers when you multiply by 1. This is like our 1. So 3 times 1 is 3, you get out the same answer. This times the identity gives you the same answer. Okay. Next one, geometry of linear equations. Okay, so when you're solving linear equations, we've got 3 possible things that can happen. Okay, you could get a unique solution, just one solution, so one x and one y value, for example. You could get no solutions at all, or you can get infinitely many solutions. These are the only 3 possibilities. So let's have a look at what they look like. If you graphed both of your equations, right, the solution is where they cross, right? If they only cross at one point, then that's where our solution would be. At that particular x, y, that would be our unique solution here, okay? If there was no solutions, if you've got these straight lines, linear equations, and there's no solutions, that tells you they must be parallel to each other, okay? So this case, you'd have 2 lines that are parallel to each other and they never cross, okay? So they must have the same gradient in that case. The same gradient, then they're parallel, they don't cross, therefore no solutions. Here, we've got one with infinitely many solutions. Now you might be thinking, why would that be? There's only one line. That's because both of the lines lie right on top of each other. I'll just put another line on top of that one. Okay, so 2 lines there. They're effectively the same line. Okay, so if your lines lie on top of each other, then you've got infinitely many solutions because it's crossing infinitely many times. You can pick any point along the line and you'll know it'll be touching a point on the line that lies below it. So if you've got that, you've got infinitely many solutions along that line. Okay, so let's do an example so you know what I mean. Here we are. We've got 2 linear equations here. Okay, so let's have a go at solving for x and y. Okay, so let's have a go. I'm going to rearrange this first equation and get a y. So from equation 1, so I'll write that as y equals 2 minus m minus 2x. Okay, so this is going to take a little while. This will be quite a complicated one to solve, I suppose. All right, so let's put it in. We're going to put it into the second equation, so sub into equation 2. What do we get? We got mx plus 2y, which is 2 minus m minus 2x equals to k. Okay, so can we simplify that at all? Let's expand the bracket. Plus 4 minus 2m minus 2x equals k. All right, we'll move the 4 over to the other side. So we've got to be a little bit careful all the time, making sure we'll get things right. Equals k minus 4. Okay, so now we've got the x's on this side. So let's bring the x out and put everything else in a bracket. So we've got mx minus 2m minus 2, bracket. So that's just taking out the x as common on this side. You can expand this bracket out. So I get mx minus 2m plus 4x is equal to k minus 4. Add up the m's. I've got minus m here, mx minus 2m. Okay. Oh, sorry. What have I done here? I shouldn't have written x in here because I took it out. Sorry. There we go. Get rid of that. That's better. That's why you show all your steps and go back and fix them. Okay. So what have I got? I've got minus m plus 4. So I've got 4 minus m. X equals k minus 4. So therefore, x is equal to k minus 4 on 4 minus m. Okay. So now that I've found x, what does y have to be? So I can put that back into my equation 1 up there. So I'll put a box around that. So I've got that. I might do it over here. It's got a bit more room. Okay. Now, I can probably do it in one little step. Let's see. Y equals 2 minus... Oh no, this is going to take ages. All right, forget that idea. Let's do it up here. Y equals 2 minus m minus 2 times x. Now x is equal to k minus 4 over 4 minus m. Okay, so what do we do with that? Let's multiply this one by 4 minus m over 4 minus m. So we get 2 4 minus m's minus m minus 2 multiplied by k minus 4 all over 4 minus m. Okay, so I've put them over a common denominator here. Okay, so basically I just cross multiplied this by, oh no, I've mucked it up. Rats. Oh no, I haven't. No, I'm good. Okay, so multiply this by the 2. Okay, and then I'm all good. All right, so expand it out. What do I get? 8 minus 2m minus, what do I get here? I get mk minus 4m. Ooh, actually, do I get minus 4m? I get plus 4m. There's a negative out the front here. Just make sure. So I've got to swap the signs of whatever I get in here. I get negative 2k, so it's going to be plus 2k. And then plus 8 all over 4 minus m. Okay, what have I got here? I've got, oh no. Oops, should have been, that's positive 8, but then I've got to swap the sign. Forgot to swap the sign. Hopefully you're yelling at me to get the signs right. Okay, there we go, minus 8 to that goes. Cancel those out. What else have I got? I've got 2m here. Okay, so I've got 2m minus mk plus 2k over 4 minus m. If I want to, I could just have k like this, 2m, I could take out k, or I could take out m. I could have 2m minus k lots of 2 minus m, maybe. Oh no, because I've got the minus out the front. Damn. Okay, so let's make that plus, and then go. Make that plus, go 2k minus m. There we go. Over 4 minus m. All right, so we've got a This is our y. I think that's as simple as I can get it. Okay, so what can we tell about here? Now we've got a fraction. We never like the denominator of the fraction to equal 0. So I never want an m. I can have an m is an element of R, but I don't want it as long as it's not 4. Because if it's 4, then the denominators here are going to equal 0. And that's no good. So as long as m's not 4, it doesn't matter about k. It doesn't matter what k is. So k is an element of R. So if that's the case, I've got option 1, which is a unique solution. So as long as this doesn't happen, I've got a unique solution and I'm good to go. Okay, so that could be any value of m. Okay, but what happens when m equals 4? So that's type 1. Yeah, type 1. If m equals 4, what are the options I can have? So let's put 4 in for m into our equation up the top. So our equation up the top, so for equation 1, if m equals 4, I get 2x plus y equals 2, and 4x plus 2y equals k. Okay, so I've got two things that can happen here. If k was 4 here, see how this is double this, the coefficients are double here. So if this answer was double, right, if the k was 4, then all the coefficients and constants would be doubled each other. It would be the same line because I could divide everything by 2 and get the same thing happening. So if k was 4, I get infinitely many solutions for m equals 4 and k equals 4. But if k was anything other than 4, then I would just have no solutions. Okay, so if k was an element of R except for 4, then no solutions. Okay, that's a tricky one. All right. Okay, let's see if we can do this system of linear equations with 3 unknowns by hand. Okay, so what are we going to do? We're going to pick 2 equations and eliminate a variable. Okay, so we're going to try and eliminate the variable x. Okay, so we're going to use equation 2 and 3. How are we going to eliminate the variable x? Well, let's multiply this one by 3 and then minus them away from each other. So equation 2 times 3, okay, so that's going to be 3x plus 9y minus 12z equals negative 21, okay, and then we've got equation 3 underneath. Okay, so we're going to minus them away from each other. What do we get? Okay, we get 3 minus 3, 0x, 9 minus y, 9y minus, we get 8y, you get it. Negative 12 minus 2 is negative 14z, negative 26 minus, negative 21 minus 5 is negative 26, okay, and we get an equation. All right, now let's take equation 1 and 2 and eliminate the x. Okay, so we're going to have to multiply this one by 4. So we'll multiply equation 2 by 4. Okay, so what do we get? We've got 3x plus 12y minus 16z equals negative 28. So 4 is 28. And then, oh, sorry, I've mucked that up. That's not 3x. It's 4x. Good. And then we've got equation 1, which is 4x minus 2y plus 3z equals 4. No, equals 1. Equals 1. Not multiplying this one by anything. That's done. Okay. This one minus this one, I get 0x plus 14y. This one minus this one is minus 19z equals negative 29. Okay, so then I've got those two, and now I want to try and eliminate one of the variables here. Let's try and eliminate the y's. So I'm going to have to multiply this one by 14. So I've got 14 by 8, which is 112. 112y, and then 14 times 14 is 196. Z equals negative 26 times 14. I don't know, I'm going to have to look that up. Negative 364. Is that right? 6 times 14, yeah, 364. Okay, hopefully that's right. And then I'm going to multiply this one by 8 to get the same y coefficients. So that's going to give me 112y. 19 by 8 is 152 z. And 29 by 8 is 222? No, 32. Yeah, 32, of course. 32. There we go. All right. So now, minus these equations away from each other. That minus that is 0. The difference between those two is 44z. Difference between these two is 132, and that's negative. Okay, so then we get 44z 132. Z goes into that nicely 3 times. Okay, so that's lovely. We've got z. Now we've got z, we can find y. So we'll put it into one of these. Let's put it in this one. So we've got 8y minus 14 times 3 equals negative 26. So we've got 8y minus 14 times 3 is 42. Minus 26, so we'll add 26, and that gives 8y equals 16, which means y is equal to 2. That's lovely. Let's see what x equals. Now, we can probably just put it into that equation number 2, because that's an easy one. We've got x equals minus 3y plus 4z minus 7, that'll equal x. So negative 3 times 2, because y is 2, plus, let's just do it, it's easy, minus 7. What's that? Minus 6 plus 12 minus 7 gives me 6 minus 7 is negative 1. Okay, so we've got x equals negative 1. Excellent. And that's it.